Hi, everyone. We'll start the webinar in just 1 or 2 more minutes, give people a chance to join that are still getting dinged on their calendars. Hang with us for just another 60 seconds.
Feel free to chat in the chat. And we actually have a survey that we're testing for the first time. So I think you have to click into the survey to fill it out. It's a simple one question poll. If you are dying for something to do, then we have that for you.
Okay, let's give it a shot. And if you join late or you have a coworker that wants to see this, there's a replay available, so you don't miss anything. Welcome, everyone, to How to Plan High-Scale Load Testing, a webinar from Gatling. Today, I'm joined, well, let me introduce myself first. I'm Sean, Product Marketing Manager at Gatling. And today we have Heather Thacker, our new developer advocate, joining us. Heather, I'll hand it over to you for an introduction of yourself and our topic for today.
Hey everyone, great to be here. As Sean said, I've been developer advocate here. I'm the developer advocate at Gatling, and I've been here for about a month or so. I've been working in tech for about 8 years, mostly as a software developer and as DevRel in DevOps for about 2 or 3 years. And yeah, I'm really excited to discuss this topic today. And it's definitely the beginning of a longer set of conversations. So on the next slide, we'll see a little bit of an outline of what we're going to go over. So before Sean's demo, we'll cover 3 different areas. First, we'll look at some technical fundamentals, reading the warning signs like how to identify the health of your Gatling test through the reports and when your test infrastructure could use some adjustments. Next, we'll consider some testing strategy and why incrementally ramping up the test is beneficial instead of just jumping straight to the target load size, because progressive load testing is better for finding your system's true breaking points. We'll also touch a little bit on capacity planning for outlier events like Black Friday or marketing campaigns, those spikes in traffic, and how to calculate your infrastructure requirements when those happen. But before we get into those things, what does high scale mean to some of our customers? So here are a few examples and just some numbers to think about. We have a telecom company with over 100,000 requests per second. We have an airline company that has over 5 million daily visits, and also a streaming service with over 15 million users connecting in 90 seconds for a sports event. We have more customer stories like this on our site if you're curious to see what some other companies have achieved. But high-scale load testing isn't really about hitting those arbitrary numbers like millions of users. It's really about testing loads that are significant and relevant to, or relative to your business context. So for most organizations, high scale means testing at 80 to 200% of your peak traffic, but this definition can really vary across your infrastructure. What does that mean? Well, for example, your authentication service might see a peak of 10,000 requests per second during the login surges, but with the checkout service, it peaks more at like 500 requests per second. So high scale can really mean something very different for different services. And so to define this for your applications, we can start with analyzing your traffic patterns over the past 6 to 12 months or longer and identify those absolute peaks and what may have caused those surges, like marketing campaigns or one-time events. And we can consider the growth trajectory and business risk tolerance from there. So if you're planning aggressive growth, you can define high scale as like 150 to 200% of your current peak traffic. And if you're preparing for a known event like a sports championship game or a flash sale, then you can model the expected concurrent users and multiply that by like 1.5 for a safety margin. And for those business critical services, we want to test beyond the expected capacity to find where the system really breaks. For the less critical services, we can test at 100 or 120% of the peak traffic. That could be sufficient, but we definitely want to document these thresholds as part of the performance SLA, so that everyone, engineering, product, and business stakeholders, they can all share this common understanding of what high scale means for each service and what capacity guarantees are being provided. So as I kind of mentioned earlier, we have a poll in the webinar. We'd like to see, we're kind of curious what high scale means to your business model. So let us know what sort of range of requests per second you're seeing at your max capacity for the business models. And for this next slide, we'll have a look at one of our customer tests. In this example from a real test, we have over 2 million TCP connections, and this was in preparation for a sports streaming event. And when you're simulating this kind of load, the generators kind of become like a critical infrastructure that needs monitoring. So in this case, the test infrastructure needed over 50 load generators for over 2 million TCP connections to simulate over 2 million users in 2 minutes. And this validates that the app can handle that traffic. And in this company's case, it was the first successful attempt in doing this with load testing, which validates that Gatling could simulate this capacity. Okay, so let's look at some troubleshooting that you may encounter with the text infrastructure on this next slide. So a common issue that we can adjust for is the effects of a JVM warm-up. A sharp CPU spike at the beginning of a test is often a cold start, and we have a few ways to address this. First, we can add a ramp up or a do nothing period at the start of the test, giving the JVM a set amount of seconds to ramp up. Second, we could use Gatling's time window feature in the UI to filter out the portion of the test before running it so that the graph doesn't include the warm-up period. And third, we can trim the first period of seconds from the analysis after the test is complete to have clean data without the cold start artifacts. We'll have a look at this a little bit later in Sean's demo. And if you ever have questions about how to implement some of these tools, let us know at another time. And another thing to really watch for at this scale is DNS issues or connection limits. If you're opening like hundreds of thousands of connections per minute, you might hit OS level connection limits, ephemeral port exhaustion, or DNS resolver bottlenecks. But before we get into those, let's have a look at a load generator issue. So on this next slide, you'll notice that like the CPU is maxing out on the load generators, and that's usually a key warning sign that you need another generator. So this is kind of what it looks like when your load generator is the bottleneck or one of the bottlenecks. So looking at these two graphs together, the bottom one shows CPU usage climbing steadily until that pin where it hits 90%, and then it kind of stays at that level. And then at that the top graph at the same pin, the response times were stable for the first 4.5 minutes or so, but then exploded from milliseconds to seconds, where the test is no longer very reliable, and soon it completely breaks down as the load keeps increasing. And at this point, you're testing your load generator capacity and you're not really testing your application. So that's something to look for when running your tests and starting to ramp up capacity. Next, we'll look at a graph kind of reflecting a DNS issue. And for the CPU one, that was something that we generated internally just to give an example of CPU usage. But then for this one, DNS connections this is an example from a customer, and DNS connections is one of the more like cryptic issues to identify, and it often shows up in other parts of your test results. So in this example, the user encountered an issue during a load test using an AWS private location with Gatling Enterprise. The requests began dropping after a gradual increase in load, and observations from metrics and screenshots suggested increased transmitted TCP segments, connection choking, and a rise in open file usage, indicating system-level contention. Further analysis pointed to potential DNS resolution issues, with Gatling recommending trying asynchronous DNS resolution as a default, because the default Java DNS resolver can block under stress. So after applying that change in the configuration, the team confirmed that the issue was resolved, and that led to the requests being closed successfully. And that's all I'm really going to say about DNS issues. That's probably a topic for a different webinar to go deeper into. So looking at this next slide, we're going to switch from troubleshooting to kind of how to strategically plan for a high scale load. So this probably sounds really basic, but start with a smoke test. It's running a single virtual user or a handful of users through your complete workflow. And this will verify that your test works and your endpoints are reachable and that you're not going to burn through your infrastructure budget testing broken code or some other small fix. So the 5 minutes running a quick smoke test can really save hours later. Next, you want to define your success criteria before you start. You want to know what your performance SLAs are. If you're trying to shoot for 95th percentile response times under 2 seconds or like error rates below 0.1%. We want to define these test assertions so that we have pass-fail criteria. Next, establishing the baseline. We want to run a moderate load test, maybe 10 to 20% of the expected peak, and observe resource utilization. We want to see that the CPU, memory, database connections, and thread pools are all responding okay. And this baseline tells us what healthy will look like. It reveals the starting point, the starting capacity before we start adding more complexity. Once we have that baseline, we can stress tasks beyond the capacity. And this is where it starts to get interesting, where we don't want to stop at the target load, but we want to push further to see what is breaking first, if it's the database, the cache layer, the load balancer. We want to know how the system fails. We want to know if it's gracefully failing with error messages or catastrophically failing with cascading failures. And we want to see how it recovers. Is there self-healing or does it need manual intervention? Finally, we want to validate at the target load. Once we know the system's limits and we've fixed the breaking points, we can run the high scale test at the actual load that we're planning for. And this is the capacity validation, the test that tells you whether or not you're ready for that big event. So this progressive approach gives you valuable data at every step, and you're not flying blind into a 2 million user test, hoping it works and skipping all the steps in between that will give you clues along the way about your system's health. So you're building that confidence incrementally, and you're understanding the system with depth, and you're able to articulate what you have and where the constraints are. So that's all I kind of have around that. If you have any questions, we will have some time at the end to answer those and discuss those. But now let's see some of these concepts covered in action with Sean's demo.
Okay, thanks, Heather. I'm going to start the demo with one last slide in the presentation. This is a screenshot from Gatling's e-commerce demo site, and it's the basis for the demo today. Most people have experienced slow loading times, items unreliably being added to your cart, or broken checkout workflows on e-commerce sites. And these issues often arise due to performance problems in the underlying application or services. To show how high-scale load testing helps you identify your application's capacity limits, we're going to test the checkout workflow. So imagine adding an item to the cart and then clicking the checkout button to go to the screen for your credit card information, but not just you doing it, but maybe hundreds or thousands of users trying to do this at the same time. This is sort of a classic example of a performance problem, and to do this, I've built a customized version of this workflow. So if you go to our demo app, you won't see the same experience that we're going to show for the rest of the demo. What are we doing? We're simulating many users adding items to the cart, the system validating the item inventory, and then completing the purchase or users abandoning their shopping carts. There's some branching logic in this example. Poorly handled and abandoned carts are a typical case where application performance can break down due to bad database design or other underlying issues. All right, let's get started. And I'm going to switch out of, oops, excuse me. That's going to switch out of this view and move over to Gatling Enterprise. So we're in the Gatling Enterprise interface now. And we're going to be working with this shopping cart simulation here. So I'm going to open the simulation. And the first thing I'll do is start a new run. And then while that is running, I'll go through some of the earlier runs of this test and talk about the results. So let's go ahead and do this and confirm. And that's it. That's all it takes to start a new run in the interface. So let's take a look at some earlier test runs that I did to set up for the demo. The first one in here is labeled smoke test. And we can just take a quick look at this one. It's just as Heather described earlier. I put some notes in here. It's an injection of 10 virtual users all at once. And the purpose of the test is really to verify that all the endpoints are working, that the test logic works, and to prepare to do capacity testing on the application. So we don't really need to go any further into the details on this test other than to look at the summary page and see that we had no errors. There were 96 total requests, the 10 max users that we injected at once, and a P95 response time of 285 milliseconds. Depends on what you're trying to do with your application, but this is a respectable time under many, many circumstances, including e-commerce apps. Now, let's move on to an example of a capacity test of the same system. So in this test, the first thing that you'll see when we're looking at the summary screen is that there's this kind of red box showing you that there's an assertion that failed. And here, we asserted that for the 95th percentile response time should be less than 5 seconds. Pretty generous. And in fact, it was more like 10 seconds. So right away, I know I need to do an investigation to try to understand the underlying performance issues for this test. And just as a comparison to the data we were looking at on the smoke test, instead of 10 max concurrent virtual users, we're looking at something more like 6,700. Now, what I'd like to do is walk you through like how I would approach analyzing this test that failed an SLA. I'm going to click over to the Reports tab, which in our the Enterprise Edition platform gives you all the detailed reporting for an individual run. And the first thing I'm going to do is actually scroll down to the very bottom of the screen. The logic that I like to use when I'm looking at one of these tests, which is sort of reflected in the way Heather talked about designing and running the test earlier, is to start by validating that the load generators were healthy for the test, that the connection data is healthy for the test, and then I can get into the details of how the application responded to the test and try to identify where performance issues might have arisen. So I'll start by expanding the load generator tab. And here we can see kind of classic data about load generator performance. The one that we're the most concerned about for our purposes is to check the CPU usage in percentage. I'll point out two interesting things. I'm going to take this off for right now. I'll point out two interesting things on this graph. The first one is that our overall CPU usage is at, maybe this one right here is the peak. It's around 27%, sorry. So that's well below the kind of 80 to 90% threshold that we advise you stay below for a load test. And then the one other interesting feature here is this little peak right here at the beginning of the test. I'll tell you right now that there's no users, virtual users being injected at that point. That's the JVM warm-up time right there. And you can see that it uses about 18% of the load generator CPU. This is totally fine unless you try to just hit your system with a really large amount of virtual users right at the beginning. And that's what we can account for by adding a little delay here before we start injecting users, which is what I did in this case. Okay, so our load generator health looks good. Let's move up and look at the connection health. DNS resolutions. We can just quickly look at this and see that our max duration percentiles are about 30%. That's, sorry, not 30%, 30 milliseconds. That's fine, we're not too worried about that. And if I go to the connections tab, we can look at the connections and see that also our connection duration percentiles are quite reasonable, down in the sort of 14 to 15 millisecond range over the course of the test, with just a few small spikes, and those still only go up to about 50 or 60 milliseconds. They might be a little concerning, but they're not too bad. So I've ruled out connections and load generator issues from being relevant to my test. So now I want to go look at what happened to the application while it was being tested. And the first thing that I will do is look at the virtual users, because here I can both describe what I tried to do, what I injected into the system, and how the system responded in terms of virtual users. You can see on the top graph that we have users arriving into the app in a classic step pattern used in capacity testing. So we went from adding, I think it's 10 virtual users on the first step per second, to adding about 110 virtual users per second on the last step. And as we look at the termination data, we can see that there is not a corresponding step pattern to the termination data, which means that we were having users get stacked up in our system. And that's also evidenced by the delayed peak in concurrent users in the system shown in the third chart. So now we know that we have users getting stacked up in the system, and we need to get a little bit better sense of what's actually going on. So I'm going to collapse this and go back up to the top of the set of graphs, where we can look at the request and response times per second and the response time percentiles. I'm going to expand this out so we get a little bit better view of it. And let's take a quick minute to analyze what is showing up when we look at request and response per second. So it might have to squint a little bit to see this, but you can see at the beginning that there's a little bit of that same step pattern that we looked at in the user arrival rates. And this makes sense. More users in the system, there should be more requests and responses as well at the same time. However, once we get to around 2 or 3 minutes into the test, the amount of requests and responses per second actually plateaus off. It's noisy, but it plateaus off for at least another 2 or so minutes of the test. This is defining the capacity of my application. If I can't exceed around 600 or 550 requests and responses per second, that's my capacity. So maybe that's what I wanted my capacity to be, but maybe I wanted it to be 10 or 100 times higher than that. But that's what it is as the application exists today. Let's see, we tried to get a higher capacity, but this is where it peaked out. Now let's go down and look at the response time percentiles and see what happened as we peaked. One of the best ways to do this is to set one of these markers up here on the plateau, and then we'll go down and see what that looks like in terms of request and response time percentiles. You can see at the beginning of the test that we have relatively fast request response times with a mean value of 46 milliseconds and that P95 value of around 100 milliseconds. But by the time we reach the plateau, we're up closer to 1 second for the P95 value and around 500 milliseconds for the mean value. So here is where we start having a performance degradation in our application. So now we know that there's a performance degradation and we have an idea what our peak usage is. And what we'd like to do is investigate the underlying cause. And I've added one more little detail into this simulation to help us diagnose the ultimate cause. I'll just remind you that we're simulating this shopping cart experience. So all of these transactions involve the database, adding items to the cart, checking out, etc. And so maybe the database would be a good suspect for what would be going wrong with our system. So I added this health check request before all of the database calls in the scenario, and there's one after the database calls as well. So if we click on the health check, this is hitting the API with no database interaction. And so if the database is the problem in our system, then we should have awesome performance on this endpoint, even if the database is slow on the subsequent calls. At least that might be the first suspicion that you would have. And what we can see here is that, in fact, this health check also degrades in terms of response time and ends up with like over 8 seconds to do a health check at the beginning of the run. So now I'm at the point where I've analyzed my load test results. I know I have not met my performance targets. And I know that even my API calls that don't call the database degrade over time. And I would like to be able to investigate further. And this is where load testing is really part of a broader observability umbrella. And we need to look at our server-side observability data to go further. So I'm going to switch back to our presentation and go down one slide and restart this. Okay, so these are the observability data from the same test run. And what we can look at here is the Postgres CPU and the underlying application CPU data here on the top left. And we can see that when we hit peak load, the Postgres database CPU was maxed out at 8 virtual CPUs consumed, and but while the application data was only utilizing about 10 to 20% of its available resources. So we can rule out from this that the application was the bottleneck, and it looks an awful lot like the database was in fact the bottleneck. Let's try to make some sense out of that and see if we can tell a story that would give us a better sense of how to move forward and investigate the root cause. Okay, so here are summary points from what we looked at in the load testing results and what we looked at in the observability data and how we could interpret this and sort of give us a very good direction for looking at the underlying code to find the root issue. What did we observe? We observed a latency cliff beyond 500 requests per second. So after we crossed that threshold, the response times blew up. We had health checks in there that don't access the database, and they also slowed down. We know that the database CPU is saturated, but the application CPU remains relatively lowly utilized. So from that, we can conclude that the database is the primary bottleneck, that probably, we would need more data to know this definitively, that slow database responses exhaust the database connections, and then application request threads block and queue. And this queuing causes a global latency inflation without errors that also affects our API endpoints, the health check endpoints. So the final result is that we have an idle or relatively idle application masking severe downstream contention. And this is a classic example of what we can reveal with load testing and combining it with observability data, which allow us to like investigate and future-proof our applications for larger loads down the road. And that is the end of the demo. And we have a Q&A here. If you have questions, there's the chat available, and there's also the questions tab at the bottom. And we'd love to know what you think of about high-scale load testing, what problems you're encountering, and maybe if there's a topic that we could delve into in more detail in a future webinar, broadly related to this topic. So don't hesitate to ask questions if you have them. We'll hang around for a couple more minutes, and if there aren't any questions, we'll see you at the next webinar.
Thanks, thanks, Sean, for the demo. I think it's great that we can pair some like theoretical lecture parts with seeing it in action with the demo. And it's also, it does kind of point to what we have coming up in terms of webinars around observability and also content. I think we have blog posts around different types of testing strategies. So we try to tie everything in from one to the next. And I mean, of course, it's the holiday season, so we're all gonna like check out maybe for the next couple of weeks. But in January, I think, I know I'm certainly working on another webinar on observability and seeing how integrations work and kind of drawing a bigger picture and seeing where like performance testing fits in with DevOps and platform engineering as a whole.
Yeah, I think it's really exciting. And if people weren't aware, I should have touched on that during the demo probably, but we do have direct integrations now with both Datadog and Dynatrace available. And I'm sure it's a topic that, yeah, between webinars and other content, you'll be seeing a lot more about observability from us in 2026.
Yeah, for sure. I think Diego and I are working on a webinar showcasing one of the customers who use Datadog with Gatling. So that one should be a fun one. I think it's for January or maybe February. So be on the lookout for that. And I see within the chat, we have a question. So to work with Gatling, do we need to write Scala script or aware of any programming language? So we do have a couple of SDKs. So you can bring your languages to the table if it fits in with one of our SDKs. So while Gatling open source is written primarily in Scala, and you can use Scala or Kotlin, we have a Java SDK, which is probably, I think, the most used one we have. And then we have a JavaScript and TypeScript one, which is also quite popular. And is that it? No, I feel like or those are SDKs.
Yeah, those are the 5 languages that we support. And if you want to use Gatling without writing code, we have 2 options. The first option is that we do have a no-code test builder in Gatling Enterprise Edition. It allows you to build realistic but relatively simple scenarios. We have customers that use it for under specific circumstances. If you're just getting used to writing tests, you can use it and then generate a test as code from the no-code builder as a way to get started and to look at like a full test layout. The other option is Gatling Studio, which we released just recently, which is gives you the ability to capture browser-based actions and convert that into a load test as well. Oh yeah, JavaScript. We love JavaScript. Yeah, we have a JavaScript SDK, and it's something that you can definitely get started with pretty quickly. There's a section in the documentation to help you get started, and we have a community forum if you run into any questions about it.
And also, if you prefer to skip the forum, you can reach out to one of us. I will offer myself on LinkedIn or something if you have any questions or want to talk more about using JavaScript, the SDK with Gatling. And I will be working on more content with the JavaScript SDK. So that will be coming in 2026 as well. And yeah, let us know what you think. Looks like we have a question. Let's see here. Could you show how to configure NB concurrent users in a run? They were
Oh yeah, the number of concurrent users in a run. Okay, good question. I didn't show the code for the test that we ran. This is I can do that actually, I think. let's see here.
And also this recording is available for a replay. I think you should be getting an email about it, or we will post about it when it's available. So feel free to watch the whole thing if you'd like, but let's have a look at this code.
Yeah, so I wrote, this test is written in Java using our Java Maven version. So basically we have two broad categories of how we inject users into a test. If you want to control the number of virtual users that arrive at your application, that's what we would call an open workload model. And if you want to control the number of virtual users that are in the application at any one time, that's a closed workload model. So there's those two broad categories, and you've got to decide which one of those you want. And then after that, you can model the injection virtually limitless ways because of the flexibility of test as code. So in this case, the way that the injection works is this is an open injection. So this is adding users to the system independent of how many users are already in the system. And this is that staircase pattern where it starts with 10 seconds of doing nothing, and then it adds 25 users to the system per second with an interval of 5, or repeats that 5 times with each level lasting 45 seconds. And then these are the ramps like this. So this is the basically the plateau period. And then at the end here, this is just basically setting how many virtual users it starts from. And it's a variable, and I can tell you right now, it's set to 10 in this particular test. So that's just one example. But we have a lot of examples in the documentation for how to do this. And if you need a little more help on this, I would really encourage you to open something on our community forum. We're really responsive over there, and we're super happy to help you model the injection profile that you need.
And looks like we have a question from James. We noted that we've done testing, or customers have done testing for millions of stream users. Can we speak to support for unicast versus multicast streams for testing?
That's a good question that I don't know the answer to. I like that question. James, I need to talk to our solutions engineers and our tech team to know a better answer to that question so that I don't embarrass myself today. But I will gladly get back to you with an answer.
Yeah, I am still learning all the ins and outs of our, high scale load testing. So I think that maybe that's a topic for the next webinar, of really looking to how we do testing for millions of users, especially within a quick couple of minutes.
All right, let's take a last call for questions. Maybe wait like another minute or so, and then from there we can end the webinar. Let's see, just move back over to this slide so you don't have to stare at my poorly written code.
I do have to reply to James on LinkedIn at some point, so maybe by that point I'll have I'll have an answer for you. It is a very interesting question that I also want to know the answer to.
I think we had somebody else. Here we go.
How is the capacity testing initiated in Gatling?
So I think if I understand the question correctly, I think we do basically, to run a capacity test in Gatling, you need to have an injection profile in your test that, not to sound overly simplistic here, but test the capacity. So how you do that, the one I just showed is that kind of staircase pattern is a pretty classic capacity test model. We have it in the documentation. It's called stairs in the documentation. If you look at the injection profiles, it's pre-built. You can build it yourself, but there's a pre-built method in there that allows you to achieve that pattern by just adding the time and the time increments and the number of virtual users. Again, I think if you want to just test something to see how it works, the no-code test builder in the interface also allows you to click on capacity test as a choice for the type of test to run. Okay, cool. I'm glad that was at least a little bit helpful. Yeah, so Heather, if people on the webinar would like to get a hold of you, what's the best way to find you in the virtual world? On LinkedIn?
Yeah, send a pigeon. Carrier pigeon is my preferred method. Yes, LinkedIn. You can find me, or through email, good old email, hthacker. And I think those are, yeah, those are the best ways.
Okay, and I'm terminally online on LinkedIn, so don't hesitate to reach out if you have a question or an idea for a topic that we should cover in a future webinar. We're always really interested in what our audience thinks and what they would like to hear about. And I think with that, if it's okay with you, we will stop the webinar.
Yep, I think that's all I've got. I debugged the devs to see if they had a response to the unicast versus multicast, but I think we'll have to just save that for another day.
Probably, yeah. Well, thank you everyone for joining, and I hope you got something out of this, and we are excited to see you at a future webinar.
Hey, thanks everyone.
Bye.